Hi friends, in this session we are going to see the equation of motion for multi-degree of freedom system. Now first, what is meant by this multi-degree of freedom system? See, the number of independent coordinates which are required to represent the system is called the multi-degree of freedom system. In simple language, if we have suppose 3 mass and 3 displacements which are given to these 3 masses, then for this system these 3 displacements are the number of independent coordinates which are required to represent the system. So means degree of freedom of this system is 3. So just see whatever I am saying here. I have shown the 3 masses and 3 displacements. Means to represent this system we will have to give the equation for x1, equation for x2 and equation for x3, then and then only this system can be represented. And if I determine x1, x2 and x3, then these are the 3 displacements. To determine these 3 displacements we will have to initially find out the equation of motion, that is the differential equation of motion. So in this session we are going to determine the differential equation of motion for this multi-degree of freedom system. Okay, multi-degree of freedom system means the number of independent coordinates which are required more than 2. So I have taken the 3 coordinates. You can take more than 2, 3, 4, 5 or n number of coordinates. Okay, so I have taken the 3. Now to draw or to determine the equation of motion, first draw the FBD of the given system. So I am going to draw here FBD of this given system. Now how to draw this FBD? So for that I am going to show the masses again. So this is the first mass, this is the second mass, and this one is the third mass. Okay, as per the system I have shown the 3 masses, M1, M2 and M3. Now show the displacements, the first displacement, the second displacement and the third displacements, x1, x2 and x3 respectively. Now show the inertia forces acting on each mass. The inertia force normally we represent in the opposite direction to motion, and it is mx double dot, but here the mass is m1 and here the displacement is x1. So for second it is mx double dot, that is m2 x2 double dot. Okay, and for third it is mx double dot, that is m3 x3 double dot. Okay, now I have shown the displacement, the inertia force. Now the remaining thing here is the spring force. So if I consider x2 greater than x1, as I have shown earlier videos, that when the x2 is greater than x1, then the spring will be elongated. Means this spring K will be elongated. Elongated means this end and this end will move in opposite direction. So this is the displacement of the spring. As the displacement is in opposite direction, ultimately its force will be like this. So these are the forces acting on this spring. Okay, now I'll show these forces here. Now this force will be K into X. So K into X, so here X will be x2 minus x1 because the spring is connected to 2 masses. So it is having 2 displacements. So it is x2 minus x1 and the stiffness is K1. Similarly I can write here K2 x3 minus x2. Okay, so this is the spring force. So I have shown 3 masses with the forces acting on each mass. Now for equilibrium condition, I am going to write the differential equation of motion. So consider the first mass. So here I'll consider the mass 1, and for mass 1 I'm going to write the differential equation. Just see this one. I'm going to consider the upward, that is inertia force, positive. So m1 x1 double dot, then this force minus k1 x2 minus x1 will be equal to 0. We have two forces on mass 1. One is the upward, one is the downward. So upward I have considered positive, so downward ultimately it is negative. So simplify this one. So m1 x1 double dot minus k1 x2 minus minus plus k1 x1 will be equal to 0. So this is the first differential equation. Okay, so this is the differential equation from mass 1. Similarly, I'll write here for mass 2. Okay, so mass 2, this is the second one. Now write the differential equation. m2 x2 double dot, that is upward, then this downward force minus k2 x3 minus x2, then this upward force plus k1 x2 minus x1 will be equal to 0. Now simplify this one. So m2 x2 double dot minus k2 x3 minus minus plus k2 x2 plus k1 x2 minus k1 x1 will be equal to 0. Now whatever the terms which are common, yes, you can take common. So here you can see the x2 is common in these two terms. So I'll write m2 x2 double dot, then first I'll take the term of x1, so minus k1 x1, then I'll take the term of x2, I'll take x2 common from these two, so in bracket it will be k1 plus k2, and then the last term minus k2 x3 will be equal to 0. So this will be the equation number 2. Now similarly write for mass 3. So the third equation for mass 3, so I'll write for this mass 3, just see here, m3 x3 double dot, which is upward, and this upward force is positive, k2 x3 minus x2 will be equal to 0. Now multiply inside. So m3 x3 double dot plus k2 x3 minus k2 x2 will be equal to 0. So this will be my third differential equation. So we got the three differential equations by FBD. Now solution of all the equations is, solution of differential equation, above differential equation for 1, 2, 3 I'll write here. So x1 will be x1 sin omega t. This is the equation of motion for SHM, and vibration is with SHM. So the solution will be x1 is equal to x1 sin omega t. Similarly I'll write for x2 sin omega t. This capital X term is nothing but the amplitude, and the x3 will be capital X3 sin omega t. Okay, so these are the three solutions of the above equations. But in above equation, if you see, then there is another one term, that is x1 double dot, x2 double dot and x3 double dot. Now what is this x1 double dot, x2 double dot and x3 double dot? These three are, means x1 double dot, x2 double dot and x3 double dot are the accelerations of the given system. Now the given system we can convert into the matrix form, or if you want you can put all these values of x1, x2 and x3 in the above equations. Now convert equation 1, 2, 3, convert equation 1, 2 and 3 in matrix form. Now why I am converting this in matrix form? Because they are asked to determine us the equation of motion. And how to determine this equation of motion? Convert them into the matrix form. So for that we will have to consider only first term. Only first term from this 1, 2 and 3. So for that I am going to write, see, there is acceleration x1 double dot, x2 double dot and x3 double dot. Okay. Now we have to write the value which is with that acceleration, that is m1, m2 and m3. So as we are writing in matrix form, so m1 0 0, 0 m2 0 and 0 0 m3. So to write this one, just see, if I multiply by this row with column, so the first equation m1 x1, then 0 and 0, means in first equation we don't have x2 double dot, x3 double dot, so here these two terms are 0. In second equation we don't have x1 double dot and x3 double dot, so these two terms are 0, and for last we have x3 double dot, so first two terms are 0. Now plus I'll write for displacements. So just check the displacements. We have three displacements, x1, x2 and x3. So I'll write here x1, x2 and x3. So the initial first term that we have with this matrix. Now I'm going to write the matrix for the displacement. So just see, for first equation, what is the coefficient along with the x1? So it is k1. So here I'll write k1. For x2 it is minus k1. So I'll write here minus k1, and here we don't have the x3, so it is 0. For second equation, just check, minus k1 for x1, then for x2 k1 plus k2, and for x3 it is minus k2. Now for third, just check this equation. We don't have a x1 term, so it will be 0. Then we have x2 term, it is minus k2, and for last x3 it is k2. Okay. Now so we have written the first term, then x1, x2, x3 term, so the right side which is remain, and that will be equal to 0. So now how to write again from this matrix form to any equation? So how to write? Just see, first row into column plus first row into column is equal to 0 will provide you the first equation. See how to write the first equation? First row into column plus first row into column equal to 0 will be your first equation. How to write third equation? Third row into column plus third row into column will be your equation. Okay. Now this is the equation of motion. Now sometimes in some exams the Maxwell's reciprocal theorem is asked, and here I am going to explain the Maxwell's reciprocal theorem. Just consider, for this is the matrix, now just see this term and this term, these two are equal. See this one and this one, these two are equal. This one and this one, these two are equal. Okay, so whenever we write any stiffness matrix, see here I'll show, this is the mass matrix, this is the acceleration matrix, this is the k means stiffness matrix, this is a x means displacement matrix, will be equal to 0. So mx double dot plus kx is equal to 0, means this k is nothing but the stiffness matrix. So whenever we write the stiffness matrix, then in that stiffness matrix, see the first element is k11, second K21, third K31, then K21, sorry here K12, K13, sorry, so K21, K22, K23 and K31, K33, K32, K33. Here K12 and K21 is equal. So K12 is equal to K21. Just see from this one. And K13 is equal to K31. Similarly, K23 is equal to K32. Means we can write from this as Kij will be equal to Kji. Okay, so Kij will be equal to Kji. So this is nothing but the Maxwell's reciprocal theorem, and up to this point this is the equation of motion. So I have explained both the terms, that is the equation of motion for multi-degree of freedom system and Maxwell's reciprocal theorem. Thank you.